Good morning, everyone, and welcome to this lecture. This is lecture number, I think, 11, or I think 12 in collision, and we are dealing with collisions. In the previous class, do you remember what we did? What was the discussion in the previous class? What we were discussing in the previous class? What we were discussing in the previous class? No one remembers? Hmm? What we were discussing in the previous class?
Types of collisions, sir.
On basis of energy.
Types of collision we had seen this coefficient of restitution, velocity of separation divided by velocity of approach along the line of impact, v2 minus v1 divided by u1 minus u2. Then we had seen perfectly elastic collision. We had seen that the value of E is equal to 1. Perfectly inelastic collision, value of E is 0. If it's the one-dimensional collision, then the bodies will move together. And then we had seen the type of collision which is possible, which is nothing but inelastic collision. Do we remember this? Yes or no? Now, as I told you, we will be dealing with central collisions and the simple type of the most simple type of collisions that we are going to deal first of all would be collision in one dimension or collision in a straight line, collision in one dimension or collision in a straight line, head on collision or direct collision. You can write the heading head on or direct collisions. Head on or direct collision. Now, to deal with this head on or direct collision, what we can do is you can take a general case. We can take a general case and then we can write the equation for that general case. We can write the equation for that general case and this is the general case that we can take. Remember what we are dealing with here are velocities and momentums. All of these are vectors. Now, if all of these are vectors and we have taken a general case, we have to assume some direction as positive. So we are just assuming that this direction is positive. Here in this sample that we have taken, all the velocities initially are in the same direction. Finally, they are also in the same direction. So negative sign will not come anywhere. But there could be questions where the balls collide like this. So if the momentum of one ball is positive, the momentum of the other ball would be negative. So we have to be careful of positive and negative. Now, this is the initial scenario. This is the same case that I told you before. There is one ball. Please listen to me, then on the right. Don't write anything right now. I'll give you time to write. The initial case is one ball moving with a higher velocity is going to impact the ball which is ahead, and after collision, the ball which is behind will be moving with a lesser velocity, and the ball which is ahead will be moving with a higher velocity. Do we understand this condition? Yes or no? Now, what we can do, what all things are known to us. Normally, the things that are known to us are masses m1, m2, velocities u1 and u2. What is unknown to us is the value of v1 and v2. Do we understand this? So in all cases, in almost all scenarios, what we are supposed to find out is the value of v1 and v2 in terms of u1 and u2. Now, how are you going to find the value of v1 and v2 in terms of u1 and u2? Anyone, any idea? How are we going to find the value of v1 and v2 in terms of n1 and n2? Here I have not told you what type of collision is this. Well, it could be any type of collision. We are solving the general case. What all things we can use to find out the value of v1 and v2 in terms of u1 and u2? Yes. What all things can we use? I have already given you what all things we can use. What all things we can use to solve this question? I have to get the value of v1 and v2. What all things we can use? Yes.
Coefficient of restitution.
We can use number one, coefficient of restitution. So we can make an equation of coefficient of restitution. Whatever is the collision given to you, the value of E, either it will be given to you or you will have to find out the value of E. If they ask you to find out the value of E, they will give you the value of V1 or V2, any one of them. So first is we can put the value of E. E will be known. If it's a perfectly elastic collision, E will be 1. It's a perfectly elastic collision, E will be 0. Any other collision, E will be between 0 and 1. So you can apply the value of E. What will be the value of E here? How will I write the value of E here?
One, sir.
What is the value of E here? How will I write the value of E here?
V2 minus V1 by V1 minus V2.
Very good. We can write it as V2 minus V1 with proper sign upon U1 minus U2. This will give you first equation. This first equation will give you the relation between V2 and V1. But remember, there are two unknowns and only one equation. We cannot solve V2 and V1. We need one more equation. From where will we get the next equation? From where we'll get the next equation? Yes. From where we'll get the next equation?
Center of mass before and after collisions.
Yes, we can get it from center of mass before and after collision. If you look at the velocity of center of mass before and after collision, we can write m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2 divided by m1 plus m2. It is going to get cancelled. This equation can be written as from the center of mass, or you can also call it law of conservation of momentum. Initial momentum plus initial momentum is equal to final momentum. These are the two equations. You can get the answer from here. Whatever be the case, you should be able to get the answer from here. Do we understand this? You should be able to get the answer from here. If I can if I can give you a question. Anyone understands this? Okay. Have you I'll give you 2 minutes to write it down. Once you write it down, let me know. Then I will move ahead. Well, then you can apply this. On this and solve this question. Two particles, one is having mass m, another is having mass 2m, moving like this. Velocity of the first particle is 2v, the velocity of the second particle is v. They are colliding elastically. They are colliding elastically. That means the value of E is 1. Find their velocities after collision. Also find the fraction of kinetic energy lost. What will be the fraction of kinetic energy lost? You must know the answer for this one. What will be the fraction of kinetic energy that is lost? What is the fraction of kinetic energy that would be lost? What will be the fraction of kinetic energy that would be lost?
1/4, sir.
1/4, sir. Okay. I'll give you 2 minutes to solve this answer, to get this answer. So how are we supposed to do it? This let us call as the initial condition before collision. This let us call as final condition. I have just assumed that they are moving like this. This is my assumption. If my assumption is wrong, V1 and V2 will is right. V1 and V2 will come positive. If it is wrong, they both can come negative, or one of them can come negative. Anyways, the first thing is I can apply the value of E. E will be equal to V2 minus V1 divided by U1 minus U2. What is the value of E here? What is the
1,
value
sir.
of E here? Yes?
1.
1. 1 will be equal to. Now, V2 is not known, so I will write it as V2. It is in this direction, and I have assumed that this direction is positive. So V2 is positive. Minus V1 is also positive. How much is U1? So let me call this as U1 and this as U2. How much is U1?
2V, sir.
U1 is 2V minus how much is U2?
V. Minus V, sir.
Minus V. From here, I will get one equation. What equation I am going to get? V2 minus V1 is equal to 3V. This is equation number 1 that I have achieved. Now I can write the next equation, which is law of conservation of momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Can you tell me what is M1, what is U1, and tell me their value so that I can put it here?
M2V plus 2 mv.
So M1 is M and V1 and U1 is 2V. So it is 2 MV. What next? Minus 2 MV is equal to MV1 MV1 plus 2 MV2. Do we understand this? From here I will get the equation V1 plus 2V2 is equal to 0. These are the two equations that I will get. Solving these two equations, you should get the value of V1 and V2. Can anyone tell me what is the value of V1 and what is the value of V2? I'll give you 2 minutes to give me the value of V1 and V2. Well, the answer that you are going to get, V1 will be minus 2V and V2 will be V. That is the answer that you are going to get. So basically, this ball is going to move backwards with a velocity of 2V, and this ball will continue its motion forward with a velocity V. That is the answer that we were looking at. The next part of the question was, what is the fraction of kinetic energy that is being lost? Well, you can find out the initial kinetic energy, half m1 u1 square plus half m2 u2 square. Then you can find out the final kinetic energy, half m1 v1 square plus half m2 v2 square. And then you can subtract them. What is the answer that you are going to get? What fraction of kinetic energy will be lost? What answer are you going to get? This is an elastic collision. What fraction of kinetic energy will be lost? No one remembers it. Okay. As expected, the loss in kinetic energy will be 0. This is a perfectly elastic collision, and therefore the loss in kinetic energy would be 0. Please remember it. I'll give you 2 minutes to write down the answers and let me know so that we can move forward. So this is how this question is solved. Every question that comes in this type, you have to solve it like this. You have to apply the value of E, and then you have to apply the law of conservation of linear momentum, solve the equations, and get your answers. You can do that, or I have created a shortcut for you. Instead of doing all this, you can apply the shortcut and get your answer quickly. Now, what is known to you in the first case is U1, U2, V1, U1, U2, and M1 and M2. V1 and V2 are the unknown. And you know that the velocity of the center of mass actually remains constant. So, using all those things, I've created a formula for you. The first thing is you can find out the velocity of center of mass. The velocity of center of mass you can find out with m1 u1 plus m2 u2 upon m1 plus m2. Everything will be known to you, so it will be easier for you to calculate this. Once you have the velocity of center of mass, straight away you can calculate the value of v1, and you can write v1 as vectorly also if you want to. V1 will be equal to 1 plus E times velocity of center of mass minus E times of U1. This is a very great formula. That will help you avoid all those complicated calculations and all those equations. Just find out VCM and then just put this equation. To find out the value of V2, the formula is similar and it is very easy to remember. Minus E times U2. Once you know this, the question becomes pretty simple and straightforward. Let me apply this formula in the question that we have done just now. This was the question that we did. We did it in this way. Let me do it in the way that I have told you. Let me find the velocity of center of mass here. What will be the velocity of center of mass? What will be the velocity of center of mass? This multiplied by this plus this multiplied by this. But remember, one is negative. So what will be the velocity of center of mass divided by total mass? What will be the velocity of center of mass coming in this case? What will be the velocity of center of mass coming in this case?
0, sir.
Zero, sir. So velocity of center of mass is zero. That makes the answer very, very easy now. So if I want to find out the value of V1, I'm not writing it vector. 1 plus E times 0, so it doesn't matter. Minus E is 1. Remember, E is 1. So 1 multiplied by U1. U1 is 2V. So you can see the value of V1 is straight away coming as minus 2V without doing all this. To find out the value of V2, 1 plus E is 1, 1 plus 1 times 0, minus E is 1, multiplied by the initial velocity U2. It is in this direction, so it is minus V. You can see the value of V2 is coming as plus V straight away without much effort. I was able to find out the value of V1 and V2 without doing all these things. So I don't have to do this. I don't have to do this. I can straight away get the answer from there. I'll give you 2 minutes to note down this. Not this. This I have just explained how it is done. This is the formula. You can use that formula in the previous question. I'll give you 2 minutes to get the answer. Let me know once you are done. Also, there is one more formula, a general formula that you have to remember. Sometimes they ask you what is the change in kinetic energy. Remember, final kinetic energy, if it is not elastic collision, is always less than the initial kinetic energy. Sometimes they ask you what is the loss or what is the change. Change is kinetic energy final minus kinetic energy initial. You can write this formula minus m1 m2 upon m1 plus m2 into u1 minus u2, which is v relative square divided by 2 into 1 minus e square. This becomes a general formula to find out the change in kinetic energy. Remember, there is a minus sign here. That means the final kinetic energy is always less than the initial kinetic energy. So these two general formulae will help you in solving almost 99% of the question that come in this particular topic. I'll give you 2 minutes to note down this answer. Then let's move ahead, sir. This is the next question. A ball of mass 2 kg moving with a speed 5 meter per second collides directly with another mass 3 kg moving in the same direction but with a speed of 4 meter per second. The coefficient of restitution is 2 by 3. Find the velocities after collision. I'll give you 2 minutes to give me this answer. So everything is moving in the same direction. Velocity of center of mass, I'm just going to use that shortcut that I've created is m1 u1 plus m2 u2 upon m1 plus m2. How much is this coming? Everything is moving in the same direction. This is
22
2
by
into
5.
5, 10 plus 3 into 4, 12 divided by 5. So it is coming as 22 by 5 with a plus sign. I can straight away find out V1. V1 will be equal to coefficient of resistance 2 by 3, 1 plus 2 by 3 multiplied by 22 by 5 minus E is 2 by 3 multiplied by 5. You solve this and you get the value of V1. What is the value of V1 that you are getting?
4, sir.
V1 is coming as plus 4, so I will take that as an answer. Then you can find out the value of V2. V2 will be 1 plus 2 by 3 times of 22 by 5 minus 2 by 3 times of 4. What is the answer that you are getting from here?
14 by 3, sir.
14 by 3. Now you have changed your answer. You were telling me 10 by 3. 14 by 3, and that is the correct answer. Also find out the change in kinetic energy. So give me the answer for change in kinetic energy also. How much kinetic energy is lost? So give me the formula of change in kinetic energy. Not the formula, find out the change in kinetic energy. There are many ways in which you can find out. You know the value of V1, V2, U1, U2, or you can find out half M1, V1 square, M2, V2 square and subtract it. Or you can use the formula that we have created. I am giving you 1 minute to give me the answer for change in kinetic energy. What is the formula for change in kinetic energy? Delta KE is equal to minus M1 M2 upon M1 plus M2 into U1 minus U2 whole square. I made the bracket wrong. U1 minus U2 the whole square divided by 2 into 1 minus E square. So if I put the values here, change in kinetic energy will be minus 2 minus M1 into M2 is 2 into 3, 6. M1 plus M2 is 5. U1 minus U2. So 5 minus 4 is 1. 1 square is 1. 1 by 2. 1 minus E square is 4 by 9. And you will get your change in kinetic energy from this formula. Do we understand this, everyone? How this is done? Yes or no? Okay. Then let me present to you this one. And I hope you can give me the answer for this one. block of mass 5 kg moves from left to right with a velocity of 2 meters per second and collides with another block of mass 3 kg moving along the same line in the opposite direction with velocity 4 meters per second. If the collision is perfectly elastic, determine the velocities of both the blocks after the collision. If the coefficient of restitution is 0.6, find the velocities of both the blocks after the collision. Give you 2 minutes to give me the answer. So how are we supposed to do this? First of all, let us find the velocity of the center of mass. Velocity of center of mass is m1 u1 plus m2 u2 divided by m1 plus m2. So what we are going to get as velocity of center of mass? One is moving from left to right, so let me call this as positive. The other one is moving in the right to left, let me call it as minus. The velocity of center of mass is plus 5 into 2, 10, minus 3 into 12, 3 into 4, 12, divided by 5 plus 3, 8. So the answer I think I'm going to get is minus 1 by 4. Yes or no? Minus 1 by 4 meter per second. Now in first case, let me find out the value of V1. V1 will be equal to 1 plus 1. Coefficient of restitution given is 1 into minus 1 by 4 minus E is 1 into 2. And from here, you should get the value of V1. What is the value of V1 you are going to get from here? I think you are going to get minus 5 by 2. Is that so? Then I find the value of V2, 1 plus 1 into minus 1 by 4 minus 1 into its velocity is minus 4.
7 by 2, sir.
I think you are going to get 7 by 2 in this case. These are the answers for the first case. In the second case, V1 will be equal to 1 plus 0.6. Coefficient of restitution is given as 0.6. But the rest of the things will remain same. Minus 1 by 4 minus 0.6 into 2. What is the answer that you are getting in this case?
Minus 1.6, sir.
The answer that I have is minus 1.6. To get the value of V2, we just need to put the values correctly and calculate the values correctly. If you can do that, you will end up with the correct answer. And the answer that I have for this is 2 meter per second. Plus 2 means it is going back from left to right. Do we understand this question, how this is done? Well, this is head-on collisions. We'll do some more questions on head-on collision and then we'll see 2 or 3 questions on oblique collision, the type which are more likely to come. So I'll see you in the next class. I hope everyone has understood what we have done here. And I hope that once you go back home, you will revise them and try them again. So I will wind off this class here. Take care and God bless you. Everyone has understood what we have done today. Okay, you have the sheet of this with you, so you can try the questions from that sheet also. Take care. Bye bye, everyone. God bless you.
Sir, we don't